My name is Goodall Salima. I'm a solutions architect at Inc. And I'm here to share with you a topic on network as a service, the future of enterprise connectivity. All right, we'll go through the introduction, the market. Thank you. The market overview and trends, how we'll be able to Uberize the network, and some challenges and opportunities of network as a service. And of course, just an overview of how the products will be built, and also just a snapshot of how we built our network as a service as Inc. So maybe taking you back a bit, for enterprises to connect, say, from one office to the other, maybe they have some resources at the head office that they want to utilize. They were using such technologies. So you're looking at T1, E1, you're looking at microwave radios between offices, satellite communication between offices, you're looking at frame relays, and so on. But then just two of those technologies persisted. If you look at the years from 2000 somewhere up to 2008, you had technologies like MPLS, which are still used to date, and also VPNs. So you look at some of the pros of MPLS. You look at it's reliable, it has better quality of services, and it's suitable for real-time applications, things like, say, VoIP or even video conferencing. But then the upset is that it is expensive, and it's very challenging to deploy on a large scale because of the expenses as well. And deploying such a technology also takes a lot of time. And if you also look at the other technology, which is a VPN, the good side is that it's very cheap because you're utilizing the same DIA connection. And it's also easy to deploy and scale for remote users. But then the upset is that it's dependent on the quality of the internet, which makes it hard to control the quality of service. And also, the traffic itself is not optimized for other applications such as VoIP and teleconferencing. But then, as good as those technologies are, we're talking about an enterprise. So with an enterprise, they have evolved. How they use the applications in the office, that has evolved. So you're looking at now that apart from having servers in-house, now things like the cloud happened. Yeah, they have some software as a service subscriptions which they're utilizing, and they also have some apps which are currently running on the cloud. So you look at now the technology of MPLS, because for MPLS to happen, you actually have to have a circuit plugged into the cloud, and that traffic is relayed now to that MPLS POP and then relayed to the client. So in terms of scalability, it's very hard with MPLS connection. Yeah, and you also look at things like the cost limitation. Considering that MPLS is very expensive, you can't actually put or terminate your connection to each and every cloud provider. That will be very costly for you. Similarly, there are such challenges as well with VPN. Things like if you want connectivity, say if branches are connecting to the head office, there's often a bottleneck which is caused if, say, maybe it's only the head office with the resources to manage the security of the company. then all that traffic from the branches goes to the head office and then is branched to the internet. And that causes a bottleneck, or maybe you have to cough up more so that you have a large service pipe or bandwidth allocated at the offices. But still, it's also very hard to now connect to those cloud platforms directly on that VPN circuit. So, but then after these two technologies, people sat down and then they thought, I think we have a solution for this. That's when now they were coming up with software-defined networks and also something called software-defined wide area networks. Yeah. So with SDN or SD-WAN, you look at now minimizing the costs because now you're utilizing the DI connections. You can actually use multiple connections in this instance, something which was failing under MPLS and VPN. You could have multiple connections, but then there was a challenge that you couldn't use them simultaneously. So no load balancing on MPLS or VPNs. There's also another issue of scalability. Now, considering that you have multiple ISPs now terminating in your SD-WAN router or firewall, then now you're able now to implement dynamic routing where now load balancing is enabled. There is also that other advantage that with SD-WAN, it is application aware. So if you have, say, a server sitting in your DC locally, and you have some resources or apps running on the cloud, you're subscribed to some software as a service or infrastructure as a service somewhere, then that SD-WAN router is intelligent enough through using software and algorithms to check where that traffic needs to be routed to. Yeah, and apart from that, you also enhance on security, where you're now able to implement things like encryption, files, and also intrusion detection and prevention, and secure web gateways. Yeah? But then, even this is not enough, because now still enterprises need more. Yeah. Now that they have been introduced to as a service, now they are saying that why can't we have something similar to software as a service? Now it should be network as a service. Now this is now where we're going into. So I'll show you a market trend. This is an extraction of a chart by a research which was done by Gartner. So it's actually just relaying to you some information which is currently happening at in the market out there. Yeah. So if you look at the first graph, that is actually depicting a legacy network. I'm glad Brian came in before me because he has painted a big and a good picture on how infrastructure is supposed to be laid out. And this is now looking at that bit of the setup. So if you look at the legacy infrastructure on how it's laid out, you will notice that when it's not as a service, right now, if we're implementing and deploying MPLS and VPNs, you will notice that the hardware itself, we're operating on CapEx. Yeah, something which now most enterprises are running away from. They want to operate on OpEx. But then if we're implementing legacy systems, first off, there will be a cost of the equipment. And then there will be that cost of now buying licenses. There will be that cost of deploying the solution. And of course, that initial cost which will be recurring in terms of the connectivity and the service pipe which we're delivering to the client. So this model is slightly pricey, and as you see over time, you make less revenue over time because you bought the equipment once off, and it's with the client. The only thing maybe you buy over time are the licensing fees and whatnot. And But then if you look at as a service deployment, there will be, of course, that little charge in terms of the equipment because you're offering the client as an OPEX, where now there will be no need for the client to pay for that initial price. But then once you have deployed the solution, because it's as a service solution, now you're looking at the client maintaining that subscription for that equipment over time. And also you're looking at maybe the renewals of the licensing. And then you're also looking at if say a client wants to upgrade the network, or maybe there's something which is happening that requires more bandwidth, then they can easily just at a click of a button upgrade and then maybe revert back at a certain point in time. I was almost to tears with laughter when Wakisa and Kwachi were having that argument that if I wanted 20G right now, what would happen? And then Kwachi was like, no, you need to talk to our commercials. Once the commercials, you have finalized everything, then we'll give you that connection today. I was like, okay, with network as a service, there will be no such need to talk to commercials because everything, it will be self-provisioning, yeah? You will see the pricing right there, the bandwidth which you want right there, and then at a click of a button, you'll be able now to have that service, yeah? And when Brian was talking about network function virtualization, this platform, network as a service, is pretty much riding on virtualization because as we're deploying the CPEs at the clients, we're virtualizing. That means there is no vendor lock-in because at present, if say we're deploying, say, an MPLS connection to you, maybe you have equipment, say, like Cisco or Fortinet. You actually have incurred that pricing where now you have that equipment sitting with you and you are forced to renew that license each and every year. But then with network as a service, because we're using visualization, we can say that, okay, we can push in, say, an ISO for Cisco, or we can push in Juniper, we can push in, say, Fortinet. Then it's up to you now to choose that technology. There is no that vendor lock-in, yeah? And most likely, yeah. So I think the other bit which I wanted to highlight here is how we are Uberizing the network. Yeah. So with when you compare how Uber started and what was currently happening, say maybe with yellow cabs in New York, and how Uber disrupted the network. Yeah. So not to be the bearer of bad news, but then if you're offering enterprise services and you are stuck on VPN, you're stuck on MPLS, and you're stuck on SD-WAN, then I'm afraid to say that the storm is coming. Yeah? Because what enterprises will need is something or some services which Uber is offering. Yeah? So what do I mean by saying Uberizing the network? First off, it needs to be self-service. As I stated earlier, that you don't need to have that back and forth that, no, talk to our commercial and then we'll provide you with a service. No. The client needs to just go on a dashboard, request for a service, and then they have that circuit delivered to them. Or they can just go back to the service, to the platform, and then say that, okay, I need to increase my bandwidth, and then they will have a certain amount of bandwidth allocated to them. They can even time it, yeah? Say that, okay, I have, say, I have a large need of bandwidth, say maybe at midnight where I'm doing my backups, so I will need to increase my bandwidth by this much just for 1 hour, and then after that 1 hour, that traffic is dropped back to the optimal operations which we are comfortable with. There should also be that on-demand availability. So that helps with scaling up and down, as I said. And there should be that cost structure that is pay as you go. Yeah, similar to say AWS or Microsoft Azure. You actually have to choose on your own that okay, maybe if it's compute power, you choose that okay, maybe I need this much of CPU or this much of storage. The same it should apply when you're offering your services as a network. The client should be in a position to say that okay, I need this much of bandwidth and at this cost. If they're comfortable with, they'll pay it, and then they'll have the service delivered to them. And in terms of user and user interfaces, a network as a service actually should be provided as in the form of a portal, as I stated earlier, that as a network as a service. But then apart from that, there should also be APIs. Say if you have already systems which are running, which you manage your network as an enterprise, then you'll be using those APIs which are plugged into your systems, and then you'll be able to actually manage the network better. And there's also that element of automation and AI. So in terms of network as a service, we're looking at things like managing network tasks such as the load balancing, detecting anomalies, say, considering that you already have multiple ISPs in place. Say if maybe one circuit has a lot of jitter, packet losses and latency issues, then it should be intelligent enough now to switch or to load balance to another provider. Yeah. There is also an issue of automated provisioning. With this one, there should be that element that you actually don't need someone to actually go to an office and deploy a particular router in place. As I said earlier, that we're virtualizing. So even the last mile CPE, which is provided to the client, it's running, it's visualized, meaning that in terms of provisioning, you just need to sit on a single pane of glass, push some configuration. You can load it, say, with Juniper. You can load it, say, with Cisco, and then you'll be able now to push the rest of the configuration to it. So it will actually trim out some costs to have someone travel from Lilongwe to Jitipa just to install a hardware, but then you can just do that physically, as in visually, while sitting in your office. Yeah. As I said earlier, that of course under that virtual stack, there is also that element of security, where now you'll be able to encrypt and have access controls. You can also push in some firewalls, and you can be able now to look at the intrusion detection prevention. So with all this, the bottom line is to also have that element of integrating with other ecosystems. I talked about having some apps running on the cloud, and also that integration, which is to multiple cloud providers. Of course, there are some challenges with network as a service. This innovation is slightly new, but then if you are courageous enough to tackle these challenges, things like the interoperability issues, the data privacy concerns, the need to robust SLAs. And if you look at the opportunities which are there, things like the cost savings and the flexibility, the scalability of the network, the rapid response to the business needs, then you'll be able now to meet those demands which the client wants in this era. So as Inc., we have developed a network as a service product, which is Inc Fabric. So with Inc Fabric, it's able to integrate with multiple clouds, and it also has all those features which I've just talked about. You can do self-provisioning. It's of course utilizing those other technologies, things like the MPLS, the VPNs, and the SD1s. So taking all that together, then we have developed a product which is called Ink Fabric. But then, of course, the key features which are currently there is that there's automated provisioning, as stated. There's enhanced security, scalability, and most of all, it's a seamless integration. Those are some of the references for your own reading on the research which is currently there on Network as a Service. But I'm happy to take any questions which you have.
Thank you so much. Please let's give him another round of applause.
As much as we'd like to denigrate the commercial source and everything, there is an art to making a deal. And this pre-provision service, while good, in some ways takes away the flexibility of custom-made solution. Because sometimes you find that in the commercial discussions, and this is why we are actually telling our kids that the commercials done and then as technical to figure out how to do this. So in certain situations, like especially when we might need a custom-made solution for you that is not easily available from the dashboard that you mentioned. And I wanted to find out, is this strictly a funnel where you can only do this, or is there still room for customized solutions and several discussions and negotiations?
Yeah, there is room for that. I'm sure there is a percentage of the users, say on Uber, who actually say that, okay, there is this need. I don't want to be commuting on the road. Can you include, say, helicopters on your Uber list? Yeah. So if at all maybe we have that requirement that is lacking and is not available on the platform, then obviously we will include it. Yeah.
I just wanted to know a use case for on a local aspect. I see what you displayed there quite a bit more at cloud-based use, but on a local aspect, so that they can copy that to the rest of us, or to those that like to use it for maybe data center locally, if that works. So on a local aspect, how would this be implemented? And also, how do you manage the physical aspect? I know you gave an example where you're provisioning ports in Goodall, you don't need to go there, but there should still be a physical aspect here. If it's a new provisioning, connectivity is big, ISP running the network service responsible and have personnel in that location.
Yeah, so in terms of deployment, we're looking at that initial deployment being enough. Yeah. So maybe to look back and also to relate to you on the severity of how we believe our solution. We have a platform which we acquired in Switzerland called Enya. So that platform is disregarding of, say, if as a circuit for a client is online or not, but then for management purposes, that provisioned, we're calling it UCP, it's a universal customer premises equipment, is always online on our platform. So if, say, a field engineer has deployed that UCP for the first time, then it's always online on that platform. So if say maybe the client wants to change vendors, as in maybe they're moving from Juniper, say, to Cisco, then there isn't that need for that field engineer to go to that client again, because we'll be able to reach it and push whatever configuration. But then there is that initial step of actually doing that installation. Yeah. You asked in terms of, sorry, can you rephrase your first question on how to deploy it locally?
Yeah, the use case for local.
Yeah, I think as Simbanet, you have the best use case. Yeah, because if we are getting services from you, we don't need to actually call you, say that, okay, I need to increase my bandwidth. Yeah, I can just go on that dashboard, and then I'll be able to provision, self-provision that increase of bandwidth, and then that service pipe will be increased.
Thank you very much. Please let's give him another round of applause.